This is Betsy with IBACOS, the director of the Alliance. Thanks for joining us today. For today's webinar called Developing a HERS-Style Comfort Rating Method, Tim is going to lead today's discussion with Anthony jumping in on a few key points as well. The Alliance is IBACOS collaborative builder community that we created to take innovation that is going on between individual builders and manufacturers and IBACOS to bring that more to the forefront and foster collaboration between members of the industry. We currently have 75 builders. The agenda that we promote as an organization is builder driven, and the goal is to create really an open exchange of ideas and collaboration among the industry. And just want to take a moment to thank our sponsors for making today's session and all of the things that we do as the Alliance possible. And those are the folks at the bottom of the screen. So I know several of you, are on the phone today to participate in this discussion, and we certainly appreciate your support. Now, as an attendee, there will be 3 ways for you to participate. We want this to be as open of a dialogue as possible. So if you have any questions during today's session, you can either text them in through the questions function. Looks a little bit different now that they've upgraded GoToMeeting, but you get the general idea. And I'll look at those throughout the session and see if there's something that makes sense to interject at the moment. But we'll also have a couple of times during the session where we will do some Q&A. So if you've typed something in and we haven't jumped into it yet, we will be sure to, at the wrap-up, address any additional questions or comments you guys have. Both questions and comments are welcome. This is something very much in development. And then the third thing, when you see this vote sign, I sent out a quick list of questions to you guys earlier today. We're just going to do a few polls because we want to gauge where the industry is on energy efficiency, HERS, and comfort rating idea as a concept in general. So when you see that, be prepared to click a button and answer a multiple choice question for us a little bit on the fly. So Timothy Beggs has been with us for, I'd say, 6 months or so now. Has done previous work with IBACOS in a former life on the Building America program. We're fortunate to have him back on our team. He's got 20 years of experience in HVAC design, and he's really been heading up work that we're doing with Building America to look at a comfort rating metric and some other factors in heating, cooling, and ventilation as well. And Anthony Grizzolia is our managing director of our innovation programs team. So anything we do technical with the government in particular or manufacturers, Anthony leads up those efforts. And he has a unique background also having worked in the field with our builders as well on construction quality. So he has both your perspective as builders in mind as well as the broader industry perspective. So thanks, guys, for taking time to put together this session for us today. And to get things kicked off, we want to launch our first poll, which is how confident are you that a home built to energy efficiency standards is also a comfortable home? So if you can take a look at that, we've given you quick percentages to answer. So take a look and click on what you think is the most appropriate percentage for you as a participant in today's session. We just want to gauge what your thoughts are in general here. So I'm going to, now that most of you guys have voted, I'm going to close that and share the results with you. So it looks like 79% of you said that, or actually 50% of you, sorry, said that 60 to 79% confidence level that energy efficiency also results in thermal comfort by default. So that's a good thing for the guys to know as they are launching into this discussion today. And I'm going to turn now the floor over to Tim to guide you through the rest of the process.
All right, thank you, Betsy. So our purpose today is primarily to engage the industry to introduce the TCRM, the Thermal Comfort Rating Method, to begin to make the case for why we think it's needed, and to begin to get feedback about that need and the process by which the TCRM could develop. So let me tell you first about some of the buckets that we have set up for today's discussion. First, we're going to introduce the TCRM and what it could be, and introduce the concept to the industry. But in reality, what we're going to do is show how the concept is in response to many of the factors that we see in the home building industry. We hear about them from builders, and we hear about them from buyers. So we're going to review about what we think is appropriate for this and why it is needed. Next, we're going to outline what we think will make up the TCRM or contribute to it, and what some of the technical components of the metric are going to be. And then we're going to speak about some of the process that we think would occur or probably should occur to develop the metric as we move forward. So first, let's talk about the need as we see it right now in the industry. So what we envision the TCRM to be, we're calling it the Thermal Comfort Rating Method. It's envisioned to be a simple metric that conveys the ability of a home to deliver thermal comfort to the occupants. It essentially measures or predicts the ability of the house to achieve and maintain comfort within some reasonable range of criteria, including the variable and I'll say fickle occupant needs. The TCRM will take complex information, it'll simplify it into a single value. One similar example that exists out there that a lot of us are probably familiar with right now is the sleep number bed system. And the reality is that sleeping comfort is made up of a number of criteria, and those criteria can certainly vary from person to person and even from night to night. Those complexities are represented here in this image by the contour map that shows the various pressures on the person's body as they sleep. And that information is basically distilled into a single score that represents the person's comfort level. The focus here is on comfort with the person sleeping, and this person is clearly showing that she is confident that she can achieve comfort. So what is the TCRM, and what's our goal? Well, we think it's going to distill the aspects of building in residential thermal comfort in a home into a single numerical value. It'll be a score or an index on a scale from 1 to 100, and perhaps beyond. The name may evolve into another acronym, possibly. And is 100 better or is 0 better? We're not quite sure yet, but we do see some compelling reasons for each of those possibilities. And if the scale on the right looks familiar to anyone, it's no accident that it looks an awful lot like the HERS scale for home energy efficiency. That's from the home energy rating system, and it's supported by ResNet. So why is a comfort metric needed? Well, certainly people want to be comfortable, but there's a lot more to it than that. So the buckets of why a TCRM makes sense lay out like this. There's several industry trends that we see that we want to talk about, particularly about how consumers and the market seem to be evolving. Then we will review how there are other metrics for thermal comfort in the industry right now, and how each of those falls short in some way, and we'll take a look at those. And finally, there's the business case for having a TCRM, and we're sensing that there's a very strong business case for developing one, and we'll get into the weeds on that.
Okay, so we want to launch our second poll. What do you believe is the current benchmark that defines a low-load home? So I know, looking at the attendees so far today, several of you participated in the Tech Summit earlier in the year when we talked about this, really for the first time, what the glint of the idea was, and we wanted to see what you guys are thinking is the current benchmark for low-load homes, to give us a sense of what your perspectives are as part of the industry. So now that many of you have voted, we'll share the results with you. So it's almost a 50-50 split, which is pretty interesting, between 44% each for zero energy ready homes as being the benchmark, or Energy Star version 3 as being the benchmark for low load homes, and then there's a tiny percentage on 2012 ICC. So thanks for sharing that information with us as well. I'll kick the floor back over to Tim.
Great, that is interesting, thank you. Well, one thing that is clear is that each version of the codes as they come out is incrementally yielding lower and lower heating and cooling loads. So the International Energy Code is becoming more stringent as it evolves. We're seeing things like the California Energy Commission requiring zero net energy by 2020, and various state and local requirements are also becoming more stringent. And while code development is one process by which loads are being pushed downward, there are other groups in the industry that work in parallel with the codes, and ASHRAE is a good one with their ASHRAE standard 90.2 for residential energy efficiency. And a lot of time that those developing standards actually become codified language in time. So there's two parallel efforts there. There's a variety of energy and low load programs being adopted by builders as they try to differentiate themselves. And developers, utilities, and municipalities are also utilizing these programs. Examples of these include Energy Star, which has quite a high degree of market penetration right now amongst production home builders. There's the Passive House program, and regardless of its spelling, it is getting quite a bit of interest out there. There's the Department of Energy's Zero Energy Ready Home program, which we just saw in the polling question. Looks like it's getting a lot of attention. And it's also getting some developer support. Developers looking to have whole communities zero energy ready. And a program that seems to have more influence in the commercial world, but certainly has a rating system in the residential world, is the LEED program. And all of these code changes and energy programs, they certainly have the best intentions. They're looking to save energy and save consumers money that they spend on energy. They encourage renewables, they reduce greenhouse gases, they improve the environment, and they even stimulate economic activity. And they seem to be doing well in many of those areas, that's for sure. But the point that we're making here is that even if a home is able to reduce heating and cooling loads to save energy in a variety of ways, it does not mean that the home is necessarily high performing. True high performance, and this spins out of my years being in the commercial energy sector. True high performance is when a building is able to do the job that it's supposed to do, and at the same time save energy and conserve energy. So let's think back to the 1970s when energy efficiency concerns had their initial spike. Buildings became insulated better than ever, and they were certainly tightened up from an air leakage standpoint. And one major consequence that developed was sick building syndrome and resulting poor indoor air quality. It's hard for us to look back now and say that those energy-saving buildings were high performers. It took recognition of the problem of sick building syndrome and then an industry response in order to introduce ventilation standards and solutions that were compatible with the energy concerns. And the case could be made that the industry has now spent about 35 years in pursuit of that optimum relationship between ventilation and indoor air quality and energy. So let's bring this back to the home. In a nutshell, a home, its job, it's supposed to shelter and protect you and your family and give them a safe and enjoyable environment in which to live and work and play. And in order for a home to be considered a high performer, it needs to be many things such as healthy, comfortable, bright, secure, and durable, at the same time that it's being environmentally responsible and giving us value for our dollar. So right now, with the research that IBACOS and others in Building America and others around the country are doing, we're seeing that newly built homes are definitely saving energy. There's no doubt about that. But we're also seeing in our research data, and what we're hearing from builders and their home buyers, is that there are some comfort problems that are not being solved by low-load homes. And in fact, some low-load homes seem to be creating an opportunity for comfort to become an issue where that problem had not pronounced itself previously. So let's take a look at some of the data that IBACOS has gathered in our field research. We're certainly starting to see a growing set of literature in the industry in the research side of things that support the idea that comfort issues are on the rise, particularly in low-load homes. And these snapshots of the IBACOS data support that. So we worked with a builder on a townhome, and this is the first chart. And it was a 3-story townhome. It has a basement, and the enclosure design was better than what we would get by following the 2012 IECC standards. The house is about 3,000 square feet, and it has a 30,000 BTU per hour furnace. So that's a low load home for sure. And we can see in the graph that a simple cooling season snapshot, I guess, was what's to be a line chart of the temperatures in the house. We have a significant spread of the temperatures and some variation over time. But there's one room in particular, and that's the master bedroom. It's the pink line in the chart that represents the top floor of the building. It seems to really be doing its own thing. And in the second chart, we're looking at the lab house that we have here in Pittsburgh. It's an IBACOS operation. The home is very highly insulated, and it's very close to the passive house standard. It's close to 3,000 square feet in size as well, but it can operate under using a 15,000 BTU per hour furnace to meet the load. But in the heating season, we're seeing significant spikes in 2 of the rooms, as shown by this snapshot, the lower chart. So comfort issues are certainly on the rise in low load homes in particular.
Tim, question, what's causing these drifts in these 2 homes from your experience?
Yeah, thanks, Anthony. Well, there's a lot of factors that we're seeing that can result in these sort of spreads and temperature excursions in low load homes. Simple things like air balancing can be a challenge, and even having the ability to balance the air in an HVAC system can be an issue. But also the architecture and the siting of the house can play a big role. Concentrated areas of windows can allow a localized solar gain that the thermostat never sees, and so the control of the house isn't going to be in response to that load. And the fact that the overall shell is so well performing, the thermostat isn't seeing load from other areas either. And stratifications can certainly be an issue with taller structures like the townhome. And what happens is with the thermostat not seeing an overall load and responding to it, there's lesser runtime, and so there's less mixing, and so there's more stratification that can develop. So these are really good things for us to see as researchers and as participants in the building industry. It gives us some insight on where to focus, where a comfort metric might need to look at, and what we need to focus on to develop it. But we'll get into more of that later. Right now, I think it's time for a polling question.
It is. So is your business currently more successful at selling the best benefits of energy efficiency or the benefits of thermal comfort? So you can take a moment. This is just an either or. We wanted you to have to pick between the 2. So take a look and let us know. We'll give you a few more seconds to see if anything changes. Things have changed dramatically in just a few seconds. So going to close that now. And 77% of you say that energy efficiency is what is more successful for you currently in terms of selling benefits in your homes versus thermal comfort. And maybe that's because there are things like the HERS index that allow you to do that more easily. So I'll turn the floor back over to you, Tim.
All right, thank you. Well, since we're talking about selling, let's look at some of the market drivers that lead us to think about a comfort metric. So we believe that there's characteristics of consumers and homeowners and the housing market overall that are making the market ready for a thermal comfort rating method. We know that consumers are continually more aware of things like energy efficiency and sustainability and conservation. And not only are they more aware, but they're taking those things personally. They're trying to figure out what the right thing is to do and then do it. They acknowledge that they bear a responsibility in life. They're environmentally and community conscious, but that doesn't mean that consumers are selfless. So let's take a quick look at.
Okay, before you, we just got a question from someone. Before you get too far into this, I want to make sure it doesn't get lost in the dialogue. This question was posed, was operative temperature measured rather than just air temperature? So I'd imagine, Tim, that was related to the townhome and the lab home charts that you showed a couple seconds ago? Right,
that's a great question. In that case, that data was air temperature only, recognizing that there are many other aspects of comfort besides just the air temperature. So operative temperature was not measured there. We do have the many other components of comfort in our database, though, for the house.
Perfect. Thanks. Thanks for indulging me.
All right, so we have a video that's going to talk a little bit about consumers.
I really like this organic soup.
Yeah? At least we know what he's eating.
Campbell's organic soup. Made for real life.
It's on me, Spartan.
There you go.
Sorry, there you go.
Okay. So, well, we see that those folks like to feel good about knowing what's in their food and the food that they give their child. But as is so often the case, you know, they really don't know what they don't know, and they're really not getting what they think they're getting because something else is happening behind the scenes that could very well be undermining all their best intentions. So there's some parallels in home performance. But let's talk about consumers. Like the family in the video, consumers like wholesome quality. You know, those folks wanted organic soup. Well, people like things like locally grown foods and maybe grass-fed beef. They like allergy-free bedding. They like hand-knit scarves. They're into wellness, and it makes them feel good. And what's more is they like to feel good about feeling good. And what I mean by that is they like to know that it's not just a feeling. They like to know that what they're doing is actually making a tangible difference in their quality of their lives. So people also appreciate value and simplicity. They want to be able to see and sense and feel that the value and the benefit of the things that they purchase or the things that they invest in, they want to see that value. They want to sense it, and they don't want to just have someone give lip service to the benefit that they should be receiving after they've purchased some newfangled thing. So in order for them to know and understand what they are getting and that they're getting what they need it to be expressed in terms that they understand. People also like technology, but they don't want it to be complicated. They need for it to be intuitive. So let's think about the iPhone marketing that you may have heard and that you may have heard us talk about at the Alliance annual meeting. People like to speak and think in terms of simple metrics, even if they don't recognize the fact that they like to do that. So let's think about the sleep number bed that we looked at a little while ago. Well, I'm a 65. Or let's think about cars. I get 32 miles per gallon. Or maybe the BMI, the body mass index. Someone may say, I'm a body mass index of 28, and I don't want to reach 30 because that'll mean I am obese.
I don't know how many people would actually share that.
Yeah. So I said someone, right? So, and people are already used to using 1 or 2 magic numbers when it comes to their thermostat. So how many fathers have said to their kids, you better not be touching that thermostat, I pay the bill, go put a sweater on and just leave it on that number or that number. So people are used to using simple metrics. And with the information age and big data and the entry of millennials into the marketplace, the other factors that we've already mentioned are playing a role, and home buyers becoming more savvy with topics such as building science and performance housing. You know, educated consumers are good, but they can be more demanding. So when we put all these factors together, we believe that we're seeing the market is ready for something like a simple home thermal comfort index, something that gives people a simple way to gauge how well a home, which as we know is a combination of many different systems and materials and assemblies, so how well a home will be able to provide them with comfort. Something that helps them gauge the comfortability in the context of energy efficiency or energy use, so that the consumer values and concerns that we just outlined, they all become part of the equation. So we'll explain a little bit more about the ways that we think the comfort index could be used later on, and there's also more reasons why we think that the TCRM has met its time in the industry. Well, let's move on to talk about a little bit about existing metrics when it comes to discussing comfort. So we're all used to talking about comfort a lot of times in terms of temperature, and the question that we had a moment ago sort of points that out, because there are a lot of other factors related to comfort. But temperature only is what we're all used to because using thermostats all these years. But it misses out on the fact that humidity plays a role as well. So in my commercial design experience, there were more statistical indices that we use to discuss comfort, but those are pretty complex and it's not easily explained to regular everyday people. So that's probably not something that we would want to be putting out there for homeowners to utilize. So moving on, the ASHRAE 55 is actually literally the standard when it comes to comfort in the design world. And it has its own set of built-in assumptions, though. It's really not intended for residential use. And if we think of what makes men in suits at work comfortable, we can quickly understand that there's probably a limited use of ASHRAE 55 directly when it comes to homes because of the greater span of occupants and their activities and their clothing levels. And the Air Conditioning Contractors Association has a standard of quality when it comes to comfort, and it can actually allow a temperature spread from the coolest room in the house to the warmest room in the house of up to 6 degrees. But it's not too hard to understand that that can actually create a condition that most occupants could find objectionable. So these are just a glimpse of some of the ways that the industry currently looks at comfort, either for evaluation or for measurement. And while none of them seem just right for the residential industry right now to use as an index, there's certainly aspects from most or all of them that we certainly could adopt as components of what would ultimately become the comfort index that we're discussing.
Pause for a moment, go back to that last slide. There are a couple of statements were made. One was that ASHRAE 55 was in fact intended for residential use, and that it was referenced in residential air standards. And the second, slightly earlier comment was, and I think you said that by, I think you showed a Nest thermostat. But the problem with thermostats is they don't measure what humans measure. So, right. And I think you're going to make that, at least that point, I think you're going to make a little bit later in some of the other stuff that you're discussing as well.
Yeah.
But any comments on that?
Well, in practice, I mean, it is used quite a bit in commercial design, but as far as the application in the residential world, it just doesn't seem to be cutting it in order to actually make comfort a something that people can tangibly understand and communicate and compare. So let's go ahead and move on. So let's talk about the business case for a comfort metric and why builders and home buyers and others would want the industry to be conversant about comfort in this way. So comfort callbacks have traditionally plagued builders and the trades, and as we saw, that's not going to be going away as homes are built with lower and lower loads. So DuPont had done a survey of publicly traded builders that revealed that builders reserve about $7,200 per house for insurance and warranty callback costs. And a warranty callback also costs an HVAC contractor between $250 and $400 per visit. So what if there was a way to better tune the buyer's expectations so that the home, their expectations for the home that they're buying, or what if there was a commissioning list that helped build in performance better so the callbacks were significantly reduced? So the TCRM could help in each of those areas.
So it wouldn't take the full 7,200 away, but it could reduce the percentage that would be related to comfort issues.
At the Alliance annual meeting, we discussed a lot about ways that we could chip away at that value, and this could be one of those ways that we chip away at it. Absolutely. So low-load designs are creating an opportunity for more risk exposure for builders and the trades and even suppliers and potentially equipment manufacturers. So when it comes to low loads, there's a whole series of events that we can look at here. But so better enclosures end up resulting in lower HVAC heating and cooling loads, which ends up resulting in lesser airflow in the house. So there's a potential for poorer air mixing and lesser runtime, which can result in stratification and temperature swings. So I think we saw that in some of the charts that we showed. And as home loads decrease and as demands for performance remain high, the need for heating and cooling equipment to be right-sized, it's really greater than ever. There's more business pressures to push equipment sizes. And so builders want to see equipment that's smaller because it generally costs less and it can lower the price point of the house or it can increase their margins. But smaller equipment can have the problem of returning a home to a comfort level and not being able to do that as quickly as people would like whenever the thermostat is set back at night, for example. Now, larger equipment is great for mechanical contractors in the sense that it increases their margins, but larger equipment can easily overshoot temperatures and have less control. And as many people know, oversized air conditioning systems just don't manage moisture very well. So a comfort metric could be used to help guide system selection by bringing the specific performance attributes to the forefront as part of the discussion focused on comfort. So we believe that the TCRM will give builders a tool and perhaps a whole system to leverage comfort in a way to differentiate themselves in the business, much like they've done already with the HERS Index and other energy and performance programs. So with the Comfort Index, builders can quantify the ability of a home to provide acceptable comfort conditions, and they can use that in their marketing strategies. For example, it gives builder A a way to strategically differentiate itself from builder B, who might have TCRM scores that aren't as good, or perhaps builder B doesn't have any comparable comfort metric at all, and so their customers are left to just guess about comfort. So this gives the builders the ability to show their sensitivity to the needs of their buyers and to enhance whatever branding of quality that they utilize. And as we've indicated, I think already, the TCRM would make a great companion to the HERS score, and I think we would basically springboard off of the success that the HERS scale has had. So having some way to quantify comfort expectations before a house is built and sold, it'll give builders a tool to help manage the buyer's expectations and manage the risks associated with comfort, particularly as consumers are becoming more savvy with building science and performing housing, like we mentioned. We envision that there will be ways to use the Comfort Index as a way to verify performance that was promised as well. And so builders can show that a particular level of comfort is available in a home. And I think that would help clarify the waters that can traditionally be very gray, because perceptions of comfort vary widely, so having a metric would help solidify things there, and that will help reduce risk. And I think we have another polling question.
Yes, we do. So the question to you all is, do you use the HERS Index to sell or promote energy efficiency? So we'll keep that open for a few more seconds, see what response we get. And we'll close that because more than half of you at least have voted. So those of you who respond, it's about 80-20. So that's not really a shock there, but something actually I think that validates some of the thoughts the guys are having on how this TCRM could pair with the HERS Index. Since it's something that's already widely accepted and in practice in the industry. I'm going to turn the floor back over to you again, Tim.
That's great to see. Great. Well, so we talked about the builder and the benefits for the builder, but for consumers, a metric would allow the buyers to quickly make a decision and decide between builder A and builder B, for example, or maybe between house A and house B, or perhaps option A and option B for a single house. So a way to quantify the benefit of comfort and weigh it against energy efficiency allows homeowners and home buyers to evaluate things based on their own personal value system. And as we know now, the HERS doesn't provide a good understanding of comfort innately. Yeah, I think we'll just, so the video has basically made that point. So we'll go ahead and move on.
It's cute though, if you want to look at it, it's on YouTube. It's called Thermostat Wars.
And there's other, Thermostat Wars is always a fun thing, but the TCRM and the Comfort Index would actually help that as well. So looking at more overall industry need, energy efficiency programs from DOE, from government or other agencies, they've done a great job of attacking the low-hanging fruit, looking at energy savings, but things like comfort, indoor air quality haven't been addressed in that context very much yet. There's a tipping point that we're seeing right now, low-load homes and the effect on comfort and other performance values. DOE is well aware of this, and they're making an effort to bring forth programs like the Zero Energy Ready Home program that actually addresses some of the tipping point and some of those performance values. The TCRM would assist in that and focus more on comfort. And actually, I think the TCRM would allow the industry to then focus on on the energy issues that impact comfort the most greatly, and then focus can be placed on those. And looking at the comfort index as being part of an overall story. So HERS models have the ability, they model the ability of a home to save energy. But what we're seeing is occupants, maybe overriding what the house is capable of doing by plugging in heaters or plugging in fans to achieve comfort. So the TCRM would use an expanded modeling set of factors to create a comfort index that would score the ability of the house to maintain comfort. And what we're seeing is there's potentially a whole evolution of scales here that can demonstrate the performance ability of homes. So we already have the HERS score. Water scores are underway already in the industry, the WER score. We're proposing a TCRM, and quite possibly indoor air quality, durability, or other factors could become part of these rating systems and simple indexes.